So hey guys, and today is I know the exams were arriving in next month itself. So today's topic is balancing of several masses rotating in different planes. So directly if we see the numerical, so I'll read it first of all. A shaft carries four masses A, B, C, and D of magnitude 200 kg, 300, 400 kg, and you may read it. Okay, so there are three masses. Okay, A, B, C, D. There are four masses having 200, 300, 400, and 200 kg respectively, with the radius 80 mm converted into meter. B, second thing, same thing for second one. B, C, and D, same thing. Okay, now Rx and Ry is equals to 100 mm. It has been given in the question, you may read it. Okay, so here is the sentence: the balancing masses are to be balanced in planes x and y. The distance between the planes A and X is 100 mm, between X and Y is 400, and between Y to D it is 200. So if we see this diagram, that is in the plane diagram, here, okay, that's fine. So here we see this is the position of the planes. From A to X it is 100, from from X to Y it is 400, and from B to D it is 200. So the total length will be 700 mm. Okay, this one was about the position of the planes. After that, if we see this table, in this table, see there is A, X, B, C, Y, and then D. Masses are as shown. For X, let us take it as mx, and for Y, let us take it as my. Radius are 0.8 as we have already seen. And now here is the centrifugal force that divided by omega square. See, here is the formula mr. So what we have to do, you have to multiply 200 into 0.08 divided by omega square. So what about omega? So value of omega here, it is taken as 1 because there is no value of omega that is in rpm has been given in the question. So that's why we have taken it as 1. And after that, see, we have to do multiply m into r, that is if we see in the calculus. Okay, so 0. No, so what 200 into 0.08, it is 16. Yeah, so here we can see 200 into 0.08 is 16, mx into 0.1 it is 0.1 mx, 300.7 it is सात्विक 21, साइट of 24, my 0.1 my, 8 दूनी 16. Okay, that's fine. So this is how the values of this column has been arrived. Now what about this? See, if we see if we started from this point, okay, I think it will be like this. This x, here it is. If we started from this point, let's say this is the starting point. So from it is 100 mm, 100 mm. So it is in meter. Its value will be 0.1 mm. So okay. Now from this point to this point, up to this point, this is 400. So up to this, what its value will be? From this to this will be 200, right? From up to this will be 0.1, and from this to this 0.1, and from this to this will be 0.1. Okay, so here it is 0.2. See, 0.2, 0.1, 0.1. So it will be 0.4, and from here it is 0.2, right? So if we consider this distance from A to X, it is 0.1. From A to B, it is 0.2. From B to C, it is 0.1. And from C to Y, 0.1. From 0.2. Okay. So this will be here it is in the negative direction, right? So for A, for A it is minus 0.1, minus because it is before the starting point. Okay, so for if we see like B, C, Y, and D. So for B, see, from here it will be 0, right? From 0, here B, it is 0.2, plus 0 point. Okay, from B to C, from B to C it is 0.1. So from up to this, from if we are measuring from this point, right? So from point 2 plus 0 0.1 is 0.3. So here will be 0.3, and here from point, okay, 0 0.3, then here will be 0 0.4, and for this point 6. uh, so if we see in this table, same minus 0 0.1, 0, 0.2, 0.3, 0.4, 0.6. This is how the value of this column has been taking place. Now about the next column. Here is the couple, that is, as we know that omega's value has been taken as 1, okay. Now couple means what you have to do, see here is the formula MRL. So what you have to do, first of all we have already multiplied M into R, and then the same column has been multiplied by this column, another column, right? So 16 into 0.1 is minus 1.60, and yeah, the same thing has been proceeded. So as mentioned in the question, we have write values and angles of theta and masses and all that. Here is the A, B, C. A X for balancing 200 kg, and with angles 45, 70, 120. So by using this, what we have to do, we have to do couple polygon, right? So for couple polygon, we will use this column number 6. So for, see, if we draw a horizontal line from 0 to A, it is minus 1.6. C from A, it is for A, it is minus 1, minus 1.6, so it is minus 1.6 if we draw. After that, here its value is 0, so there will be nothing. From A to B, for this is 4.2. So 4.2. Now the question is how to draw 4.2 in this angle only, why it not in another one? So for this, see, we have to do, we know the angle between A to B, it is 45 degree, right? So for this A to B, if we draw it, if we keep it set square and draw 45 degree angle and draw 4.2 mm line. After that, from B to C it is 7.2. For B to C, for B to C the angle is 70 degree. So here, see, if you draw the line B to C in this direction, right, and keep your set square in this direction, like matching that horizontal line with this, so this will be definitely 70 degree. Same thing here, it is from C to D, it is, see, here it is 9.6. So from C to D the angle is 120 degree. So same thing we have to do, keep it in this direction and measure it, it will be 9.6, and the point, this last point have to join with the first point, and this what will be the your 0.04 my, because here it's the value is 0, okay, so there will be of no use. It's 0.0 my. So by measuring, see, whatever proper scale that we have used, say here it is for means for 0.1.6 we have taken it as 5 centimeter. You may take it as you means as per your suitable condition. So if we measure this length, it will and it will be compared with 0.0 my. So by this we will get the value of my, and a value of my is 182.5. After this, see, we know this line, and we will came across the value of my. So parallel to this line, take a ruler scale and draw from parallel to this line, okay, O dash D dash, parallel to this draw a line, and here it will be OMY. Measure the angle, it will be theta 2, it will be 20 degree, 12 degree, okay. So by this we get the formula value of my, but one thing is remaining here, it is same 0.1 mx and 0.1 my. Now we get the value of my, but what about 0.1 mx? So for this we have to draw what, force polygon. So for force polygon we will use the fourth column, that is here m into r. So 16 for A, it is 16. So if we draw a horizontal line from O to A, it is 16. Take suitable scale. For 0.1 mx, सिंपल सा फंडा है इसमें क्या करने का. देखो यहाँ पे ए फ्रॉम ए टू जीरो ड्रॉ हॉरिजॉन्टल लाइन, राइट. फ्रॉम ए टू बी ड्रॉ a line straightly parallel to A to B, okay. And as in the column B, it has see, it is 0.1 mx, so keep it as it is, keep it aside. And here is 21, so use draw parallel to this line and take the major value as 21. Same thing, draw parallel to this and take it as the 6, 24. Again draw parallel to this and take it this one as 16. Now after this, see, here we have measured the angle, that is 12 degree, right. So from this we have to draw a 12 degree angle. So if I give the value as 0.1 my, why it is so? In the column number 4 it is my, 0.1 my, and we know the value of my. So what is the value of my? It is 182.5. So if we multiply it by 0.1 my, it means 0.1 into what? 182.5. So the answer will be 18.25. So draw 18.25 line. It will be up to this much point, and from this join totally the last point O, from O to E, and this will be 0.1 mx. Now measure this length. It will be, so 0.1 is 1 mx is equals to length. So whatever the length has been arriving 35.5. So value of mx is equals to 35.5 divided by 0.1. It is 3.55. So this is how we have to solve this, and by measuring this angle we will get the angle, that is 145. Not by measuring, see, in this case what you have to do, measure this angle. How we have to measure this angle? For this, draw a parallel line, okay, in this diagram, that is in the angular position of masses, and then from this you have to measure from O to A. From this line to this you have to measure the angle, and it will be obviously greater than 90, means its value will be greater than 90, and its value comes up to around 145 degree in the anticlockwise. And this is how we have to solve this problem, that is in on balancing of several masses rotating in different planes. I don't have that perpendicular set square, so I have to use this.